topic by topic. Today we're going to have a look at more about reactivity. We're going to have a look at making salts from metals. There are three experiments that we need to do. We need to do one about making salts from metals, another one from making salts from insoluble metal oxides. We can make salts from carbonates, and there's another one we can do which you can make salts from alkalis. Alkalis and insoluble bases not really very different. Okay, so we're going to look at today making salts from metals. We're going to have a look at this sort of equation. We're going to take our metal plus an acid, and this will give us a salt plus hydrogen gas. So if we take a metal, for instance we take zinc, and we take an acid, for instance hydrochloric acid, then this will make us zinc chloride, ZnCl2, plus hydrogen. It's not balanced, that reaction. What we need to do, in fact, is to put a 2 there, and then it's all balanced. So we've got here our simple reaction. What we're going to have a go at is looking at this reaction in a minute. Other reactions I mentioned, though, we can have a metal, but this time let's take a metal oxide plus an acid, and that's going to give us a salt plus water. So if we take a metal oxide, for instance copper oxide plus sulfuric acid, that will give us copper sulfate plus water. And that is the experiment I have done, and I'll put a link into the bottom so you can see that experiment, which wasn't done live, so probably had a much better chance of actually working. Let's take another one. Let's take an alkali plus an acid, and this again gives us a salt plus water. Let's do it with real salt here, so let's take an alkali, which might be something like sodium hydroxide, and we add that one to our acid, which would be HCl. This is the sort of thing we tend to do in the burette, and this gives us the salt, which in this case is going to be, I was going to write sodium chloride, but NaCl plus water. And our final experiment would be a carbonate plus an acid, and that's going to give us a salt plus water plus an extra ingredient, carbon dioxide. Carbonate, could go for copper carbonate plus an acid, HCl will give us the salt, which would this time be copper chloride, plus water, plus CO2. So these are the 4 experiments that you need to remember the names of. Acid plus base, or basic oxide, acid plus alkali, acid plus carbonate, and the one we're going to do today, acid plus metal. So an acid plus metal gives us a salt plus hydrogen. And what we want to do is going to have a look at this experiment. So we're going to have a little look and see what it does and see what we can do with it. So let's have a go. Right. Hopefully I've got that all set up over here. And what we've got is I've got a little bit of zinc and I've got some hydrochloric acid, and what we're going to do first off is to try and show you that we make hydrogen. So I'm just going to put my safety specs on because I'm going to be playing around with hydrogen gas and it's going to be moderately dangerous. And what I'm going to do is going to put a little bit of acid in here, and I have forgotten to get something out. I knew I might. I want to get some sort of stand to hold my test tube in. Hopefully I've got all the other stuff out that I needed. So I'm going to put a little bit of acid in there, going to put a little bit of zinc, and then we're going to see if we can collect the hydrogen in a test tube above that. So let's just try this one out really quickly. So this is going to be a little bit of acid in there. I don't want much. This is merely a proof of concept experiment. I want a spatula and let's see what happens. So I've got some zinc powder, and this is sort of very fine sort of powder. So let's just put a little bit of that in the test tube and we'll see what happens. And I'm not getting an awful lot of reaction here. I would expect normally to get a bit more than this, but that really isn't seeming to do very much, which is worrying me from the state of my reaction that I'm going to try and do in a minute, because this is a classic way of trying to produce hydrogen gas. And this certainly isn't working very well. Well, I don't think I'm going to actually demonstrate there's any hydrogen gas in there. So this is not working very well. What could I do to try and get this going? Well, we could make it a little bit warmer, and I could take some warm acid and I can add some metal to that, and we'll see if that might work a little bit better. But we shouldn't need to, but this is certainly not producing anything significant. Oh dear. Well, something's gone wrong somewhere. My zinc metal looks fine, it works, and that looks reasonable for zinc metal. And my acid I know works, so well, we'll try. I can try a little bit from the bottom just in case it doesn't look like it's oxidized. No. Right, okay, so that does not look like it's going to be a very exciting reaction. So what we've then got to do is see if we can try and plan to do this reaction and get this one going. Right, let's have a look and see what we need to do. Which didn't work, was that simply just putting in this acid and this metal we should have managed to get, and we only need dilute to collect hydrogen, and it's a standard way of trying to make hydrogen. And what we're going to need to do is trying to put a little bit of, I think, the zinc in at a time. So let's have a look at how we might take this and make an experiment out of it. So I'm going to think that what we may need to do then is take something like a beaker, or it could be a conical flask, just as happy, and we're going to heat the acid gently. And I don't want it warm, I just really want this to be some warm acid, because I'm going to give it a chance to see if we can get it to work. To the warm acid, I'm then going to remove the heat, because I don't want a naked flame around. And what we're going to do is we're going to add some zinc. We should get hydrogen gas produced, and once we've got some hydrogen gas produced, we keep adding zinc until we end up with some zinc left. What we're then going to do is we're then going to filter this, and we're going to collect the liquid in an evaporating basin. And then that evaporating basin, then we're going to heat and we should be able to get our crystals. Now, the better way of doing it than that is usually to take a beaker of boiling water on a tripod and gauze with your Bunsen burner underneath, and let's put the evaporating basin on top, and that will gently take that. So that's my plan of my experiment. We shouldn't need very much acid, so let's say we go for something like 10 centimeter cubed of hydrochloric acid. We're going to add here excess zinc to this, and what we should then be able to do is get it working. But at the moment, for some reason, that isn't working very well. So I think we'll just try out having some warm acid, and we'll see if that makes any difference. So let's go over to the experiment, and this, I've left it for a while. It's simply not working very well. So what we could do is we could try a little bit of gentle heat on that and see if it does do anything. I'm not that hopeful, to be honest, but let's bring that over there, you can see it. So I've got my Bunsen burner, let's just light the Bunsen burner. There we go. And let's see if this makes any difference. Well, we do seem to be getting a few bubbles working. I'll turn the gas supply off. And that now does seem to be bubbling a lot better than it was. That seems to have got it going. Not really that confident that I could probably manage to get too much in the way of hydrogen out of here, but we might. We are certainly getting some bubbles now coming up. I'll put it down there so Paul can zoom in a bit better. I know he was trying, but I couldn't hold it there. I could tell I got it wrong because he gave me the look. Right, so we're collecting a little bit of hydrogen here. Let's see indeed if we have any hydrogen. Squeaky pop test. Nope, don't seem to work there. Right, okay, so we've got it working. Not enough that I can verify that this, which is, it's not that warm, I'm holding it quite happily in my hand, is producing something working. So what I am going to do is I'm going to put that aside, and we're going to take a little bit of acid, and I think we're going to warm it up just to sort of hopefully get it going a little bit. Now I don't want very much, and I said that what we want is about 10 centimetre cubed. So let's take our acid and we'll put in about 10 centimetre cubed. So really not very much acid in there, and I'm sure if I put some zinc in there it's not going to work. So let's take this and we'll heat it up just a little bit. And I'm not going to heat it up, as I said, very much. Right, so making sure my Bunsen burner hole is closed. And let's just, no, that went out. And what we're going to do is going to heat this up a little bit. So it's going to take a few moments here just to warm this up. I'm not going to warm it that hot because I don't really want it to go really terribly hot, but 50 or 60 centigrade is probably going to be all that we're going to want here. So we'll just sort of give it a few moments on the burner, just really to warm the acid through. Many of these things work better when they're slightly warmer, and if you've got a cold day and your chemicals are cold, then we need to sort of do something with that. And that's probably more than enough, so I'll put the Bunsen burner safe and we'll turn the gas off. And there's my acid. It's a little bit warm to touch at the moment, perhaps a little bit warmer than I wanted. And what I'm going to do is I'm going to add a little bit of zinc just to see what happens. So just a tiny amount of zinc, and there you can see it is bubbling quite nicely, and we are having some sort of reaction, which is what I was expecting. And we're getting hydrogen gas given off. I haven't got very much. We've got the doors and windows open, so I'm not very worried about the amount of gas that we've got giving off here. And I want to just add enough zinc till the reaction stops. Still going nicely, so we'll add a little bit more zinc. And I'm leaving that to cook really at the moment. We've got a little bit of zinc in there still. I can still see some zinc. No point in adding any more at the moment. But we are getting some bubbles given off. And basically I want to continue this experiment until the bubbles stop, because at that point we know the reaction has completed. So still going on. Now, one of the silliest things you wouldn't do now is to get the flame and put that in there, because we would then find we've got quite a lot of hydrogen, probably mixed with a fair bit of air, and that could then be explosive, and it could be enough to actually break the beaker, conical flask in this case, and cause an accident. As you can see, it's not too hot for me to hold. But the reaction is now going quite nicely. I'm just going to put the lid on that. And what I've just got to make sure now is that this reaction finishes, because I want to get rid of all of the acid, because I don't particularly want sort of acid lying around. And we seem to be now going quite nicely. Considering I was having quite a few problems trying to get this experiment to go, then it's going quite nicely this time. And I have to say I was surprised. I normally expect this to sort of be an experiment where I would do this quite happily at room temperature. But we can see, trying to hold this, that we've got still a little bit of zinc at the bottom, not reacted. And we've got a fair bit of reaction still going on. It's taking quite a long time. And I'm thinking I'm going to have to leave this for a few minutes and look at some other bits and pieces while we wait for that, because it's still not complete. And I don't want to do the next stage until this reaction is actually over. But it's quite cloudy there, you see, it's the bubbles being produced. I am trying to give it a little bit of a stir, and the reason I'm trying to do that is simply trying to get as much of this zinc exposed to the acid, as much of the zinc reacted, so that basically all the acid that's in here has actually reacted with the zinc and there's no acid left. And at the moment I can still see some bubbles being produced. chemistry is one of those things you have to be a little bit more patient with than other things. Sometimes they don't go as quickly as you want them to do, and we live with these experiments working at the rate these experiments work at. Certainly getting less at the moment. We're running out of acid to react with, so we think we can start doing and worrying about the next stage. And the next stage is I'm going to put some filter paper in here and we're going to filter it. But I'm going to try and give you a few hints on how to do this. So let's take our piece of filter paper. Many people, when they do this, what they do is they take their filter paper, they fold it in half, they fold it in half again, and then they open up just a quarter of this, and that forms this, which fits in beautifully into this filter funnel. But that's not the only way we can go about it. Having done my folds, what I'm going to do is I'm going to fold it this time in half. And I'll fold it in half again. Not convinced I got that right, but still, it won't matter. Now I'm going to open this up, and what we can then do is we can fold it along our folds, but sometimes we're going to fold them the other way. And what we should get is this now folded in a more fluted manner, and it's not on there properly at the moment, but it will do when I put the liquid in there. And this is virtually nearly reacted. I still need a few more moments, I think. What I'm looking for is to see how much it's bubbling and whether we've got anything else left. I can't see now. That much in the way of bubbles. Yes, I can see quite a lot going. So it's still reacting here. It's almost like some of my zinc's sort of not reacting and other bits are. Interesting. I'm still tempted to leave this just a little bit longer because it's still reacting. Right, okay, so it's going very slowly, I might add, and it's not that warm. For anyone was worrying about how hot it is. But we've still got some reaction going on. It's very nearly stopped. he says then it comes on a bit more vigorously. Don't think you can see down there to have a look to see how it's going, but we are getting a few bubbles. I don't think you can actually look down there. It's quite hard to focus on this for us. But there you can see, yes, just a few bubbles still coming. The thing is moving around a lot, that's because I'm holding it. So we're still getting a few bubbles. So the reaction's not quite over. I'll move it away. But it has very nearly stopped. Compare what I had. So let's see if we can get the next stage done. Right, here we go. We've got another conical flask. I've got my filter paper, I've got my reaction mixture, and what I'm going to do is I'm going to pour my reaction mixture in here. And hopefully we'll get a little bit coming out. So this also takes a little while. I've got just a little bit of liquid down there, and mostly I hope that's going to be zinc chloride solution. And now what we've got to do is try to get out this liquid and see if we can get some nice white crystals of zinc chloride. So I've got to leave that now to go for a few moments to see if we can just get rid of any more of the, basically just the zinc. We'll see if we can then get the thing going. I've still got some acid in there, which is what's worrying me. Didn't quite go. But with time constraints, I'm trying to move along a little bit. So that's just going down a little bit. I said that our options now are twofold in trying to extract the crystals. The crystals can be taken either, and it's still going there, either by just directly heating this or by heating it over a water bath. Now if we're getting crystals that have got a water of crystallization, or we're worried that they're going to spit a lot, then we tend to use this method. If we're just going to try and get the crystals themselves, then we can heat them more directly. We're going to try this system because it is safer, and what we're going to do now is simply boil some water and set this up so that when the filtration is complete up here, we'll be able to get going on that, and we haven't got very much to do. So let's set that one up. It's still just about dripping through there. Let's get the next bit set up, and what I want is a reasonable size beaker, if I go for too large a beaker, then we have problems. Too small a beaker, also not quite so good. So we've only got a small amount to go in here, so I'm going to use a beaker this size, whereas the other one is perhaps a little bit safer. And less prone to sort of have some problems. So I'm going to use a slightly smaller beaker. We're going to see where we're going to go with this. I've got some liquid down there, so we're just about ready to have a go at this, and we're just waiting now for the kettle to boil, because we want the kettle to be boiling well, so that we don't have to sort of spend all our time trying to heat everything up. So looking at my liquid coming down, it's just about stopped. We've got then some boiling water, so let's just set the boiling water in here. I don't need an awful lot, and what we're going to do is we're going to transfer our liquid into there, and let's set our Bunsen burner going. I just want to make sure my hole is shut. And let's get that water boiling. At the moment it's not mattering too much, because we've already got hot water, and the hot water is already coming up, condensing on the bottom of the surface, and we'll start to heat that water up. So here is our standard way of trying to evaporate, using basically boiling water underneath, and you'll see here it's nearly boiling already. We're getting there. We're getting quite a lot of condensation here as the hot water evaporates, condenses on this surface, and starts to heat up the liquid up here. And there we are, we're starting to boil. And that will start to cause this to evaporate, and hopefully after a few minutes we'll start to see some crystals forming. So there we are, we're boiling now. That should ensure that the temperature of that becomes really quite hot. We're starting to get some steam, definitely water vapour coming out, but yeah, really steam coming out of there. And that will heat this water up at the top, and that's going to cause that to now reduce down, and we get a saturated solution in the evaporating basin, and hopefully we'll see some white crystals start to form. None of these are really quite quick, they always take some time. It takes some time to sort of get good results, and here we didn't sort of go too quickly on this, but we didn't go too slowly either. We've got here the zinc that didn't react, and of course we've got some that's soaked in here, so that's all rubbish. So what I will now do is safely dispose of that. That's now ready for washing up. And looking down here, I can't see any crystals forming yet. But we are getting quite a lot of steam coming out there, and because we're getting steam going out there, I know all of this is round about 100 centigrade, and that's going to heat this small amount of water that we've got in the evaporating basin, and it's going to raise its temperature up, get it to evaporate, but more slowly. And so what we're going to get is left just these little crystals. He says hopefully. You can see in fact that we're actually reduced down some of the liquid at the top here. We haven't got quite as much there as we had. And hopefully we should get some crystals of zinc forming, zinc chloride. We could have done this reaction with other acids in exactly the same way, and while that's just boiling, I'm just going to have a look at those fairly quickly. Had we decided to, then we could have taken some zinc, plus we could have done sulfuric acid, H2SO4, and this would produce zinc sulfate plus hydrogen. We could have reacted zinc here with nitric acid, and this would have made some zinc nitrate plus hydrogen. Those are the two main acids that you would normally react with. So hydrochloric, sulfuric and nitric. I'll put the hydrochloric acid in there for completeness sake. Just balanced and rounded the reactions. There are, however, some other acids that we could have taken. There are a few organic acids, and one of the most notable here is one called CH3COOH, and this is acetic acid, our old friend vinegar, and that would make mist it out that way round, which is zinc acetate. There are quite a few different acids that we can do, but the main three that we run on are what we call the mineral acids to produce these things. Right, let's go and have a look back at our experiment and see how it's doing. Put my safety specs on. We're looking now round here much drier. What I'm noticing that's actually happened is you'll see that the water vapour that was all along the sides has now disappeared. This is because this has all now become really quite hot. So all this is at 100 centigrade, the boiling point of water. And what we're looking at now is just this piece at the bottom where the liquid is, with its sort of water layer. Now what I need to do is show you that easier, but it's not that easy. So what we're going to do is we're going to try and be clever, and we're just going to try and move the camera. This always upsets Paul when he didn't know we were doing this. I think if you just bring the tripod along. And now you get a good look at the printer instead of on top. There, we can see it. It's gone quite clear, and the only place you can see stuff that is here, that's where we've got this water vapor underneath. That's where we've got our liquid there, whereas the rest has all actually gone very clear. And you can see what's going on. This is the difference, of course, when we do an experiment live as opposed to doing an experiment that we've recorded, and then we can actually set up all the angles much nicer. But this is now evaporating down. We've gone from about a half, we probably got through more than a half of this while it's boiling away, and we're just left now with a little bit, which I'm hoping I was going to get a few little crystals forming. If you've got a really good imagination, you might just see some crystals starting to form around this edge. So just about here I can see some crystals forming. They're very small crystals, it's just very slightly white there. Coming around here. Try not to get my hand in the way. I'm also not trying to burn my hand as well. But here we can start to see there, little crystals forming. And once we've got so far with this, then the last little operation usually involves just allowing it to cool down and do it by itself. We're going to see if we can just keep going just for a few more moments, because unfortunately I know this isn't terribly exciting, riveting TV to watch. I'm trying to just simply watch an evaporation. Getting there, it's taking time. Patience is what we need in chemistry. However, patience isn't one of the most wonderful things we have when we're trying to watch YouTube, because at least you've got the benefit of me, that if you're watching this recorded, you can speed through to the end to see what's actually happening. You can have a look at how much acid was used, how much liquid was made, how much was evaporated off. And you can see that we started off with only 10 centimetre cubed of acid, and we're down here to probably only about 1, maybe 2 centimetre cubes of solution that we're playing with now. It's getting there. It's going down very slowly, but since I talked to you, it's gone down by a couple of mils. And I am seeing, not much, but some crystals here forming. And I think we can put this down as probably not one of my better experiments. But I can see on here some crystals there forming. Just about. They're certainly not going away in the heat, which is what we'd expect. We tried, and it should work better. It should have worked a bit faster. My normal reactions of zinc powder and hydrochloric acid, they work quite well, but today for some reason no, it's not. So to summarize, because we didn't really see it, an acid plus a metal gives us the metal salt plus hydrogen. We should have been able to do the squeaky pop, we didn't. What does come out from what we saw is that if you've got, press the wrong button, sulfuric acid reacting with something, it makes sulfates. If you have nitric acid, you make nitrates. Hydrochloric acid with something, you make chlorides. With the acetic acid, you make acetates. So this is how we name salts. One last look at what we've got. Has it made any difference? Well, yes, I can see a little bit of difference here. Pulling it around, there I can see that I've got some salt crystals made. This time the salt is zinc chloride. So we have made a little bit, we have made some, but not very much. So definitely not one of my better experiments, but that's chemistry for you. I hope you found this one not too boring. You can see how it worked. It did work, but not well. If you enjoyed it, then subscribe, and I will see you next time on GCSE Chemistry Topic by Topic. I'll leave some links in the bottom for how to make metals from insoluble bases and carbonates, and then hopefully next time we'll have a look at neutralization and the pH scale. Until then, stay safe. Bye bye.